Okay, what I've got here today is the MESR 100, and this is the Mark II version, according to the seller. It's a ESR meter. Basically what this is a AC ohm meter. So it uses a 100 kilohertz signal in order to test resistance in, for example, electrolytic capacitors, such as this one. So this is the Mark II. It comes with this nice table here of expected values, which is quite useful. Very simple user interface. You got these come included. They're actually quite nice rubber. There's also points here, so you can just insert these like that. Works best if they don't have a lot of solder on the legs. There's a little plastic clip on the back here, which I broke off on purpose because it's very flimsy. And now we're just going to power it on and test a couple of my junk drawer capacitors. So first of all, it takes a bit of a long push to turn on. Let's see here if we can get this readable on the screen there. It's not a bad screen. It's black, backlight, 2 LEDs at the bottom here, so they're fairly uneven. I think that should be just about readable, that angle. So first thing we can do is just test this, just short the probes together, and we can zero it out manually here. As you can see, it's quite high resolution. It's got 1 milliohm resolution at 100 kilohertz testing, so we can just zero that. And it's auto-ranging as well. It didn't zero quite properly, but we're right down at the noise, so that's quite good. So we'll start with this 100 mic 200 volt capacitor. Now according to the table here, a 100 mic 250 volt should be 0.8 ohms, so we'll see what this reads as. I think this should be an okay value, 0.83, which is pretty damn close. It's a 200 volt, not a 250, so that explains some of the offset. This is a 470-35 volts, so looking at the table here, we should have 90 milliohms across there. So there, actually slightly better than spec. So, excellent. The biggest downfall of this device is that it can't really measure very small capacitors. The smallest value here is 10 micro. So it's primarily designed for testing in circuit, which I'll do a test later of. But let's say this is a 10 micro 35 volts. So we'll just try putting this in the little holes here. But 10 micro at 35 volts should have 3.2 ohms. So we'll see if that's the case. That is very good. So the table here is actually quite useful, but as you can see, it also does display something on screen. Let's see what it says here. Good if capacitor less than 22 microfarad. So, that's also useful. I don't usually look at that. I just use the table. But there we go. This is 0.146. Good if capacitor is less than 470 micro. And this was a 16 volt 220. So in general, that is slightly useful, but I prefer using the table because you have to factor in the voltage rating. Higher voltage capacitor will have lower ESR typically. It is capable of measuring quite large capacitors. This is a 3325 volt capacitor. That should be somewhere between 0.12 and 0.08. So let's give that a try. That one was still charged. That's not good. As you can see, it actually survived that quite well. 0.05, 0.06. So that is actually reading with a very good ESR. The ESR is that you would expect for a 10,000 micro. So this is apparently a pretty good capacitor. Let's just see if it'll still zero. Make sure I didn't damage anything. There's some amount of drift there. So let's re-zero it and then test that again. So it does have internal protection diodes, but you're not supposed to actually use them. I'll take a look at this later. But there, it's actually reading extremely well, this. But you know, this is at the larger end of the range, and the purpose of this is not as an LCR meter. It's not designed as a measurement instrument. It's designed essentially as a go, no-go tester for parts in, for example, power supplies, where you can just measure capacitors without desoldering them and quickly say, is this capacitor good enough or is it degraded? Do we have to replace it? Yeah, I'm gonna turn it off now, and I'm gonna just comment slightly on the build quality. There's a USB port here, and I haven't tried that at all, and I don't intend to. But I suspect you could integrate this in some sort of automated or semi-automated testing if you really wanted to. Build quality is actually surprisingly good considering how cheap it was. It's built in a fairly cheap, but certainly not extremely cheap plastic. There's no real flex to it, but you can feel, it's quite hollow. You can just hear that. But the probes are good. I had to glue these on here at the base because otherwise they'd slip off very easily. But other than that, it's actually quite good. And the battery compartment's screwed in place. It came with batteries, and they still work after a few days, so I'm happy with that. The table here is very useful, and yeah, if you're doing any kind of power supply repair on modern equipment, then you do actually need one of these to confirm the ESR of capacitors. But if you are doing audio work where you're dealing with smaller capacitors or like radio circuits, then you should probably save up and get like an Agilent or something, which has a proper LCR meter and can measure that to like picofarads of capacitance and do ESR testing at multiple frequencies. To test like 10,000 micro capacitors, you actually need a lower frequency. You typically test at 100 Hertz. This does 100 Kelvin Hertz, according to the label. I suspect they mean kilo. So, I'm going to rig up a little test jig and check how it works when measuring in circuit. So I'll be right back. Okay, so I figured the best way of doing in-circuit testing was to actually get a circuit and then test in it, which is better than trying to rig up some sort of custom jig. So I'm just going to power this thing on now and try to make sure that you can see it. There we go, that's powered up. So I should probably be using a slightly shorter lens for this, but there we go. No, you don't actually need to make sure that this is the right way, but it's desirable to do so. So these are 250 volt 100 microfarad capacitors. These are not the 200, probably 350 volts, 105 degrees. These are the main input filter caps in a little switch mode power supply I use to power radios and such. It's got a little cigarette lighter output here. It's a nice little supply. I can see that looks like this is connected up as some sort of voltage doubler when used, because these are in series as far as I can tell, or it's just got a double supply. Anyway, the negative is there and then there, so I'll just hook this up. These are not ideal for hooking something like this up, but I'll try to get a connection here. 0.23. 0.23, so for a 250 volt 100 micro, we should have 0.8 as a worst case scenario. So yeah, that's excellent. It's a good quality capacitor, apparently. Fairly cheap power supply, but it was bought here in Norway. 0.26 for that one. Again, we should have 0.8 or better, and lower is of course better. And what you should note now is that there's a lot of diodes and other stuff in the circuit, and you might have across these, you might find that there's diodes across the terminals of the capacitor to prevent these from being negatively charged when they're operated in series. So that's something to watch out for. And with a tester like this, which uses very low voltage signal, it will not activate diode junctions. So the final test, let's try to get at the output capacitor here. It's a little unwieldy, but output capacitor is there. So that's roughly in frame. Let's see where it was. There, I think. 0.03. That was 1000 volts, probably 16 volts, 1000 micro. 0.09 or 0.08 is what we should be reading there for a 1000 micro at 16 volts. So it definitely works for testing in circuit. Very quickly allows me to determine that this power supply should be working. I haven't tested anything else in it, but you know, the capacitors haven't failed. They seem to be better rated than their minimum rating, which is good. Yeah, I'm not going to go into detail on this power supply, but next I'm going to connect up the oscilloscope and take a look at what sort of output signal this is producing, to check what kind of voltage it is. Or actually, I'll just hook up a multimeter and we'll take a look at what the voltage is, because we know that it's 100 kilohertz, approximately a sine wave. And then I'm going to open it up and take a look at it. Okay, so now I've got the MESR 100 hooked up to my daily driver 427A multimeter. We're just going to power it up. There. It looks like it's producing a signal already, but voltage on the 300 millivolt scale, it seems to be producing at the highest range about 110, 120 millivolts, which would correspond to a peak value of approximately, just move the camera, sorry, 120, yeah, so less than 200 millivolt peak voltage at the highest range would not activate any semiconductors except for like germanium diodes or the very best of Schottky diodes. Let's try changing the range here to manual. You can't actually do that, so that's interesting. At the lowest range now, it's actually producing over 200 millivolts average reading, which is fairly high. That might start to activate some diodes slightly. I don't think that would affect the reading too much, but it's something to be aware of. You may want to go up a range. So change the range now to 1 to 10. That's slightly lower, and then 10 to 100 actually lowers that a fair bit. I'm not sure why that's happening, but yeah, slightly high. I think some of the better ones operate with approximately 30 millivolts, usually advertised as the test voltage. And I think the Agilent model, which of course costs about 10 times as much, does operate at a much lower voltage to be absolutely sure that no semiconductor junctions can be activated when you're testing this in circuit. Obviously, if there's a resistor in parallel, then that's going to cause problems anyway, because it doesn't differentiate between capacitive or reactive impedance and capacitive. impedance. Now, in theory, I think you could test inductors as well, but I don't have any inductors that I know the value of. And I think the range would essentially make it less useful. But that is something you could use it for, but I'd question the accuracy. So I guess it's time for teardown. Right, so let's do a teardown. Non-destructive, because I do want to use this for my work, repairing power supplies from time to time, freelance. Right. There we go. Just fiddling with the exposure settings there. We'll start by unscrewing this, opening the battery lid here. East Power, super heavy duty, lead free. I hope that's what that means. Lead free, not lead containing. I'm not sure why you'd put lead in batteries though. They've worked so far for maybe collectively 20 minutes of on time, so this will not see enough use that I'm going to bother putting lithiums in here. Normally use alkaline replacement lithium batteries for heavy duty applications. I do think you could potentially use this to test battery ESR as well, at 100 kilohertz, mind you, but then there are better test methods for battery ESR. Okay, let's take a look here. Oh, that's incredibly simple. There's just the terminals here, fairly reasonably heavy. I mean, it does have zeroing, so it nulls out the values. Looks like all the components are on the bottom side. There's just this flat flex for the LCD. So let's screw this. I haven't taken this apart before, so just drop the screw. I should be able to find it later. It looks like the probe terminals are reasonably nice. They are actually all the way through here, so they probably make contact with that ring there, but you could actually drop something through the terminals and end up losing it inside the device. That's not super desirable. Okay, now I believe that this capacitor here may actually be the calibration capacitor it uses during startup. And then as we take another look here at the parts, we have an LMV824, probably a op-amp used in the measurement bridge. There's protection diodes here. These were probably tested by me already when I did this. Some slightly interesting work here with the ground plane stuff. I doubt this is anything more than a double-sided board. I'm not sure what they're using that inductor for. They might be using it as part of the oscillator or something like that. USB here, not isolated in any way, so I don't think. I think this is common ground. That's something to be aware of. You could be dumping a current into your computer ground. Unpopulated part here, and that looks like an ICSP header for this, as far as I can tell, a PIC 18F24K20, which is, I believe that series is the probably a USB compatible one, since there's no separate interface chip here. But that's actually a pretty hefty little microprocessor there. Let me just, on the fly here, Google, first of all, the LMV824. That's actually a Texas Instruments branded part. If that's genuine, then that's actually pretty good. LMV824 series, low, waiting for it to load here, low, single, dual, low voltage, low power, R2R output, 5 megahertz op-amps. That's actually pretty nice. Relatively low offset voltage. low power supply, so it doesn't use a lot of current, rail-to-rail outputs. Yeah, that's not bad at all. 1 microvolt drift. Pretty good. Not a bad little op amp that. And I think this is a quad op amp, so it's probably doing a... They might be using something like just a couple of separate measurement bridges and then switching between them somehow. There's a tiny little IC there, and there's a couple of other. There's a measure just labeled AL304, and then there's A and P. That's these two. No idea what they are, and I'm going to find anything either. But it's actually quite a nice little board. It doesn't look like something you'd get from China, honestly, except for the very cheap shell and the not brilliant banana plugs here. I'd say this board actually looks very nice. Heavy-duty little microchip circuit there. Obviously, there is room for making this more sophisticated, but you know, it's not. It's sold for next to nothing on eBay. I think I paid $40 or $50 for it. So you know, you're not going to get Agilent quality, but still, it's a nicely laid out board, I think, and it seems to be decent quality soldering. Nice, fairly recent. It seems to be a name brand microcontroller. Yeah, proper op amp protection on the inputs. I would have preferred perhaps to have through-hole mounted 5408 type capacitors here, because that way they would be easier to replace, because they're probably going to fail at some point just due to abuse by me. But yeah, the LCD screen is not brilliant, and the backlight is not great, but overall I'm pretty impressed by the circuit board. At least it's very nice. If they put this in a slightly nicer box, they could probably charge twice as much for it, because the circuitry seems to be high quality. Let's try to get it back in the box here. Yeah, not a great chassis, but a nice product. If you need to do power supply repair and testing, then you want one of these. That's what I'm going to say about it.